Hello everyone, I am Dr. Sirajul Faisi. I welcome you in my YouTube channel. Today in this video, I am going to talk about basics of organic chemistry. So, I will focus on method of purification of organic compounds. Once an organic compound is extracted from a natural source, or synthesized in the laboratory, it is essential to purify it. Various methods used for the purification of organic compound are based on the nature of the compounds and impurity present in it. So common technique used for purification are as follows. First, sublimation. Second, crystallizations. Third, distillation. Fourth, differential extractions. And fifth, chromatography. Now, what is sublimation? In this process, the solid substance changes from solid to vapor, formed without going to the liquid state, and this is used to separate sublimable compound from non-sublimable impurities. The second, crystallization. It is based on the difference in the solubility of the compound and the impurities in a suitable solvent. Then, distillation. This important method is used to separate volatile liquids from non-volatile impurities and the liquids having sufficient difference in the boiling point. Now, distillation is further divided into two parts: fractional distillation and steam distillation. Fractional distillation, if the difference in boiling point of the two liquids is not much, simple distillation cannot be used to separate them. The technique of fractional distillation is used in such cases. Now, second, steam distillation. This technique is applied to separate substances which are steam volatile and are immiscible with water. Now, differential extractions. The organic solvent and the aqueous solution should be immiscible with each other so that they form two distinct layers which can be separated by the separating formula. Now, chromatography. What is chromatography? In this technique, the mixture of substances is applied onto a stationary phase, which may be a solid or liquids. A pure solvent, a mixture of solvent, or a gas is allowed to move slowly over the stationary phase. So, in chromatography, there is the absorptions and partitions. What is absorptions chromatography? Is based on the fact that different compounds are absorbed on an adsorbent to different degrees. Commonly used adsorbent are silica gel and alumina. Absorption chromatography, first column chromatography and then thin layer chromatography. What is column chromatography? Column chromatography, it involves separation of a mixture over a column of adsorbent stationary phase packed in a glass tube. Thin layer chromatography, TLC, is another types of absorption chromatography which involves separation of substances of a mixture over a thin layer of adsorbents coated on glass plate. So, the relative absorptions of each component of a mixture is expressed in terms of its retardation factor or RF factor. Distance moved by the substance from the baseline X and distance moved by the solvent from the baseline Y. So, partition chromatography. What is partition chromatography? continuous differential partition of components of a mixture between the stationary and mobile phases. Now, friends, qualitative analysis of organic compounds. The elements present in organic compounds are carbon and hydrogen. In addition to these, they may also contain oxygen, nitrogen, sulfur, halogens, and phosphorus. So, detection of carbon and hydrogen. Carbon and hydrogen are detected by heating the compound with copper oxide. Carbon present in compound is oxidized to carbon dioxide, tested with lime water, which develop turbidity. So calcium hydroxide, carbon dioxide react with calcium hydroxide, it gives calcium carbonate and water. So hydrogen to water tested with anhydrous copper sulfate, which turns blue. 5 molecules water react with white copper sulfate. It gave very nice blue color, copper sulfate 5H2. So detection of other elements. Nitrogen, sulfur, halogen, and phosphorus present in organic compounds are detected by Lassen test. First test for nitrogen. The sodium fusion extract is boiled with iron 2 sulfate, then acidified with concentrated sulfuric acid. The formation of Prussian blue color confirms the presence of nitrogen. Now, sodium cyanide first reacts with iron 2 sulfate and forms sodium hexacyanoferrate. On heating with concentrated sulfuric acid, some iron 2 ions are oxidized to iron 3 ion, which react with sodium hexacyanoferrate to produce iron 3 hexacyanoferrate. Ferroferricyanide, which is Prussian blue in color. So 6 cyanide plus Fe2 plus, it gives FeCN6 4 minus, and 3 FeCN6 4 minus plus 4 Fe3 plus XH2, it gives Fe4 FeCN whole 6 3 dot XH2. This is Prussian blue. So test for the sulfur. The sodium fusion extract is acidified with acetic acid and lead acetate is added to it. A black precipitate of lead sulfate indicates the presence of sulfur. So S2 minus Pb2 plus, it gives Pbs black. On heating sodium fusion extract with the sodium nitroprusside, appearance of the violet color further indicate the presence of sulfur. So H2 minus FeCN whole 5 NO 2 minus, it gives violet FeCN whole 5 NOS. This is the formula where iron, cyanide and NOS 4 minus, and this compound have the violet color. Test for halogens. The sodium fusion extract is acidified with nitric acid and then treated with silver nitrate. The results, a white precipitate soluble in ammonium hydroxide, shows the presence of chlorine. A yellowish precipitate sparingly soluble in ammonium hydroxide shows the presence of bromine. A yellow precipitate insoluble in ammonium hydroxide shows the presence of iodine. So X minus Ag plus is give silver X. X represent halogens, chlorine, bromine, and iodine. Now test for phosphorus. The compound is heated with an oxidizing agent, sodium peroxide. The phosphorus present in compound is oxidized to phosphate. The solution is boiled with nitric acid and then treated with ammonium molybdate. So what results will obtain? A yellow colorations or precipitate indicate the presence of phosphorus. Sodium phosphate react with nitric acid, it gives phosphoric acid and sodium nitrate, and this phosphoric acid react with ammonium molybdate. With nitric acid, it gave ammonium phosphomolybdate, and ammonium nitrate and 12 molecules of water. So, quantitative analysis, carbon and hydrogen. A known mass of organic compound is burnt in the presence of excess of oxygen and carbon, copper sulfate, second oxide. Carbon and hydrogen in the compound are oxidized to carbon dioxide and water respectively. So CxHy plus X plus Y divided by 4O2, it gives X2O. Y by 2 is 2. What observation? The mass of water produced is determined by passing the mixture through a weigh U2 containing anhydrous calcium chloride. Carbon dioxide is absorbed in another U2 U-shaped tube containing concentrated solution of potassium hydroxide. You can see the picture. Dry, pure dry oxygen, combustion tube, copper oxide, sample in platinum board, furnace, coarse calcium oxide, copper oxide, gas, copper oxide, anhydrous magnesium perchlorate, and potassium hydroxide solution, and on asbestos, calcium chloride guard tube. So, increase the masses of calcium chloride and potassium hydroxide give the amount of water and carbon dioxide from which the percentage of carbon and hydrogen are calculated. Now, nitrogens. There are two methods of estimation of nitrogen, Dumas method and Gelda methods. Dumas method, the nitrogen containing organic compounds when heated with copper oxide in an atmosphere of carbon dioxide yield free nitrogen in addition to carbon dioxide and water. You have Cx, Hy, Nz react with 2x plus y divided by 2 copper oxide form carbon dioxide, y by 2 water, z by 2 N2 and 2x plus y by 2 copper. So this is the copper carbon dioxide, copper oxide gas, copper oxide organic compound, coarse copper oxide, this is the area of furnace, reduced copper gas, mercuric cell, here, nitrometer, here nitrogen KOH solutions. Now Zelda method. The compound containing nitrogen is heated with concentrated sulfuric acid. Nitrogen in compound get converted to ammonium sulfate. The liberated ammonia gas is absorbed in an excess of a standard solution of sulfuric acid. The amounts of ammonia produced is determined by estimating unreacted sulfuric acid left over after the absorption of ammonia by titrating it with a standard alkali solution. So, if you have organic compound react with sulfuric acid, it gives ammonium sulfate. It reacts with sodium hydroxide, ammonium sulfate, ammonia, and 2 volume of water will obtain. Ammonia further reacts with sulfuric acid forming ammonium sulfate. So this is the setup: organic compound plus sulfuric acid plus copper sulfate. This is Geldel flask. Here you can see Geldel trap, water out, water in, known volume of the standard solutions, so water inlet, content of Geldel flask after ligations of sodium hydroxide. Now, drawback of this method. It is not applicable to compound containing nitrogen in nitro and azo compound, and nitrogen present in the ring pyridine, as nitrogen of this compound does not change to ammonium sulfate under these conditions. Now, halogen carriers method. A known mass of the organic compound is heated with fuming nitric acid in the presence of silver nitrate containing in a hard glass tube known as carriers tube in a furnace. Carbon and hydrogen present in compound are oxidized to carbon dioxide and water. The halogen present from the corresponding silver halides AgX is filtered and washed and dried and weighed. So this is the setup. This is the furnace, nitric acid and silver nitrate. This is the curious tube, iron tube, and organic substance. Now sulfur. A known mass of an organic compound is heated in a carrier's tube with sodium peroxide or fuming nitric acid. Sulfur present in the compounds is oxidized to sulfuric acid. It is precipitated as barium sulfate by adding excess of barium chloride solution in water. The precipitate is filtered, washed, dried, and weighed. The percentage of sulfur can be calculated from the mass of barium sulfates. So my friends, hope this video will be helpful to you. If you like this video, then